Hi, everyone. My name is Matt Mastracci. You're in GWT Linkers. I am the CTO of DotSpots. We are a company that uses GWT extensively. Our product involves a Chrome extension, a Firefox extension. We have a website. All of these things are built using GWT. And because all of these forms are so different from each other, we actually make heavy use of a GWT feature called linkers. Okay, so I don't know what the state of the wireless is right now. It's been going up and down. Is everyone here on wireless? Do you have access to the wave? I'll be taking questions at the mic or on wave. We'll see if the network stays up. If not, I'll take them at the mic at the end of the presentation. So, IO 2010-GWT4. Okay, so let's go over the agenda. I'm going to start off the talk just briefly recapping how GWT loads code. You might have seen this in Joel's talk earlier today. They had a similar diagram, but just in case you haven't been there, we'll go over it again. We'll move into what linkers are. We'll talk about artifacts and how artifacts propagate through linker chains. We'll move on to the SelectionScriptLinker, and I'll talk about the Web Worker linker from SpeedTracer. We're going to go through a demo where we'll actually build a linker here. And depending on how we're doing for time at the end of the presentation, I'll go over some advanced linking concepts, developer-guided code splitting, development mode, some upcoming features you might want to be aware of. Okay, so we're just going to start off talking about how GWT loads code. Mentioned before, you may have seen this in Joel's presentation here. The first step of GWT's code loading process, we load the host page. This is the host page is the page specified in the URL. It's just a regular HTML file, possibly generated by your server. It has a reference to something called the selection script. The selection script is a bit of JavaScript responsible for determining the current environment of your GWT application. So this is the current browser you're running in. This is the, if you're using internationalization, which language you're running in, possibly any of your personally defined properties that you might want to switch. So it determines which permutation of these properties is running, and then it loads the permutation script. The permutation script basically contains all the information required to start your GWT module, start its entry point. And once this finishes loading, your module is up and running. GWT 2.0 introduced something new, though. I'll talk about this a bit later and how this relates to linkers, but basically you can add these run async statements in your GWT code. You can sprinkle them, and this will tell the compiler that you want to load the code later on rather than right away. If you are writing certain kinds of linkers, you'll have to be aware of how this code gets generated. So you'll have to put some support into your linker to actually make these things work. We'll get into that kind of later on in the talk. Okay, so what exactly is a linker? Everybody's deployment story is different. We have a certain form of web application at DotSpots. We use a CDN. We use Amazon CloudFront for storing all of our static files, including the files we generate in GWT. So we have a certain layout that we actually have to maintain before we actually push out our deployment. And every one of you here is probably going to have subtly different requirements in your deployment. I mean, they're all going to be very close to one theme, the standard web application theme, but there's going to be subtle differences everywhere. You may also have subtle differences in how you bootstrap your GWT application. You might want to generate basically put in certain values into your JavaScript global environment. You might want to pre-generate some data in just a little blob. Yeah, there's tons of little tweaks you might want to have on your environment. Now, the GWT team, when they came up with the idea of this linker stack at the end of the compile, instead of saying, okay, let's try to write a bunch of linkers that support every one of these use cases out there. Instead, what they did is they they took a step back. They said, okay, what are the most common ways you're going to want to deploy a web application? And let's support these out of the box, but then let's build a big pluggable stack that anybody can extend, replace, augment. Basically, it's something that you can plug into to customize it to actually make it do what you want. Something where it doesn't take a lot of work to do. So the idea behind the GWT linker stack is that it makes GWT really flexible. So you can now take something that's a Java to JavaScript compiler, like the GWT compiler parts, and then you can take that output JavaScript and you can put it wherever you want. In our case, we take a GWT module, we turn it into a Firefox extension. We take a GWT module, we turn it into a Chrome extension. We generate our website from another module. We've even got a module that publishers can just include on their site with just a little script tag. So all of these things are generated from GWT. And what we do is we use linkers to basically shape how this output looks on disk. So one thing to note about linkers is that every piece of information that ends up on disk goes through the linker stack. So ultimately, you have full control over what's on disk at the end of the compile. Basically, nothing is written that you don't have the ability to tweak or change or, throw away if you wanted to. The linkers give you full control. So I'm just going to quickly talk about the built-in linkers of GWT, because these are things that ship with GWT right away. You can use these to customize your deployment story to a small degree. So the iframe linker, if you don't do anything in your module configuration file, this is the linker that you'll get. What this does is it generates .cache.html files that are loaded from the same domain as your host page. Because they live in iframes, because of the browser's same origin policy, you can't actually serve these from another domain. They have to be served from the same domain as the host page. So for deployments that require loading scripts from another place, there's the XS linker or the cross-site linker. This generates .cache.js files, which are loaded using script tags. And because they use script tags, they're not subject to the same origin policy. And now you can load your scripts from another domain, say a content distribution network, or you can turn your GWT application into a gadget in some places. Finally, the last linker that ships with GWT here is the single script linker. Single script linker is a special linker that basically inlines one permutation that's output from the compiler into your selection script. And this linker is useful in a small number of cases where you might be writing a library that only has one permutation. You're not really interacting with the browser DOM. You're just writing something that the CPU basically just does some processing. So in this case, the linker will actually fail if you actually try to pass more than one permutation to it. So the important thing to remember here is that each one of these linkers uses the same linker stack that you have access to when you're writing your application. So if you wanted, you could duplicate the functionality of these linkers exactly without having to use any special GWT APIs or special knowledge of how GWT works. Basically, this is these are just some pre-compiled recipes for you that you can use if you want to. Okay, so I'm just going to briefly talk about switching linkers. If you've ever changed from the iframe linker to the cross-site linker, you'll know what I'm talking about here. Just quickly talk about it. The add linker declaration in your module XML file is used for this. I've got a small example here where I've taken the default GWT web application, I've compiled it. As I mentioned before, I'm not actually specifying a linker, so by default I get the iframe linker. I put in an add linker declaration, and now I get .cache.js files. And what you'll notice is that I'm not actually getting .cache.html files anymore. And the reason is that both XSLinker and iframeLinker are primary linkers. And I'm going to talk a bit more about primary linkers later and exactly what they are, but there can only be one because these types of linkers control the shape of your JavaScript so much that only one can actually run at any time. Otherwise, I mean, it just doesn't really make sense because you're either generating a Firefox XPI or a Chrome extension. You know, you're not generating both at the same time. Okay, I'm going to move on to artifacts here, which are kind of like a fundamental part of linkers and how they work. So if you're writing GWT code, you might wonder why you really need to move into writing linkers to get your output finalized. You know, you might be familiar with Ant or Bash, you know, Python, whatever. All these scripting languages which you normally use to manipulate files, to aggregate them, zip them up, etc. The reason you don't want to use Ant to finish up your deployment is that all of the metadata about the compile is thrown away at the end of the compile. What happens at the end of the compile is you end up with some raw JavaScript on disk, and there's no information about where that JavaScript came from. You have a hard time telling the JavaScript that's compiled for Internet Explorer from the JavaScript that's compiled for Firefox. It's basically, they just look like JavaScript files to you. So you don't have access to all the rich information that's available in the compiler after everything's been written to disk. So an artifact is the answer here. So an artifact comes from the compile process, but it also contains information about where it came from. So basically, an artifact says, OK, I was compiled for Internet Explorer. I was compiled for Firefox. You know, I contain the English language version of the application or the French language, or you know, other properties. Artifacts also, depending on the type of artifact, may contain other information about you know, which linker they came from, any special information there. So really, an artifact is just a piece of information passed through the GWT compile process, and then through the linker chain, and then finally, potentially written to disk. And artifacts are really just Java objects. The name artifact, of course, just comes from the base class that all these artifacts implement. So artifacts in your compile, they come from a number of places. So your module XML, if you specify script or style references, those become artifacts in the compile. If you use the public path for a module, files in the module's public path become artifacts. The compiler generates artifacts after the compile is done. They're called compilation results. The generators that run during the compile have the opportunity to emit artifacts. An example, of course, is the image bundle stuff that's you might be using right now. The generator for the image bundle actually emits the PNG files, the bundled PNG files, at the end of the generator run, and those are later found in the application's output. And another cool thing about generators and artifacts is that once you start getting into writing really advanced linkers and generators, you can actually start using artifacts as a way to pass messages from your generator to your linker, because every artifact that your generator creates is passed down from the compiler through the linker chain, and every linker has a chance to look at it. So you can basically create some information at compile time that uses the rich type information of the compiler, and then have access to that after the compile is completed and all the type information is thrown away. You may still have some information that you want to take a look at. So we'll talk a bit about this later and an example of where this is actually used. The important thing to note about artifacts is that they travel around in something called an artifact set. And this isn't anything really fancy. It's just basically a Java sorted set that contains artifacts. The artifact set, though, has an interesting set of methods which make it type aware. You can ask an artifact set to give you all the artifacts of a given type. So you may have a certain subclass of artifact that you put in there. You can ask for all artifacts of that type and all their subclasses. And you can use the artifact set as just a bag of information that you can query at all these different points in the compile process. Or you may be able to ask for types that GWT itself has, types of artifacts that GWT itself has put in there. So of course, the big example of using this type-aware property of artifact sets, every piece of information that ends up on disk as part of your compile comes from an artifact that is a subclass of emitted artifact. This is a special base class for an artifact that tells GWT that this file is going to end up on disk. And any artifact that isn't a subclass of this special class is just thrown away at the end of the compile. It just kind of disappears, gets garbage collected, et cetera. So you have to remember, if you want it to end up on disk, create a subclass of emitted artifact, and your file will then end up on disk at the end of the compile process. So an important thing, of course, to note is that even if you might not be a subclass of emitted artifact, you can still actually access all these artifacts all throughout the chain. They're still available. So you only have to be a subclass of emitted artifact if you want to retain this artifact after the compile is finished. So let's just quickly recap this, just so it's clear exactly what artifacts are and how they flow. The final output of your web application is basically emitted artifacts from the artifact set. The source code itself generates artifacts directly, files in the public path. The compiler, when it runs, outputs compilation results into the artifact set, and any generators that the compiler runs may emit their own artifacts. And finally, after the compiler runs, the linkers run, and linkers both read and write artifacts, and whatever's left basically at the end of this process is your web application. Okay, so let's actually get into the meat of the presentation, what linkers are. Linkers are basically a bunch of code that you write that runs somewhere inside GWT's linker chain. The linker chain is kind of a fancy word for just really a bunch of linkers that happen to be run in sequence using the output of the previous linker. It's really simple. You can dig through all the GWT code to see how this works, but it's really just running the linkers in order, passing the artifact set from linker to linker, and then writing the output. So every linker has what's called an order. It's either a pre, post, or primary linker. And this just tells GWT where in the linker chain your linker runs. As you can imagine from the name, pre-linkers run first, the primary linker then runs, then all your post linkers run, and at the end of that post link is where your application is written. Every one of these linkers in this linker chain, they are connected, as I mentioned before, by artifact sets. Every linker gets an artifact set as a parameter to its link method. It then creates a copy of that artifact set, makes any changes it needs, and then returns that artifact set where it's then passed on to the next linker. It's fairly straightforward, just a bunch of artifact sets getting passed around. The linker that runs in the primary order is basically the most important linker that runs during the GWT compile process. It's really ultimately responsible for how the application looks at the end of the compile, like the general idea, the general layout of the application. So, small differences between cross-site and iframe linker versus, maybe your application is ending up as a Firefox extension zipped up or a Chrome extension zipped up. These big differences, they basically come from the choice of primary linker. The primary linker is responsible for a number of things. The primary linker is basically responsible for bootstrapping your GWT application, which means figuring out the correct permutations, loading whatever permutation is active, etc. They control the deferred fragment loading as well. So writing a primary linker is definitely a much bigger job than writing the pre or post linkers. Just mention those in a couple of seconds here. So a couple of examples of primary linkers: the iframe and cross-site linkers, all the GWT built-in ones you may be familiar with, the browser extension linkers. SpeedTracer has actually written the best primary linkers that you can actually take a look at right now today. They actually have an HTML5 Web Worker linker, which I'm going to talk about in a little more detail in a few minutes here. This is actually available in the SpeedTracer source code, so you can take a look at this during or after the talk and see how it actually works and play with it if you wanted to. And as well, the SpeedTracer team actually has a Chrome extension linker in there. It's rolled into the SpeedTracer source, but it's something that you can use if you wanted to compile your own GWT modules to Chrome extensions. If you are writing a primary linker, I mentioned that primary linkers are responsible for so much. When you write a primary linker, you are actually responsible for making sure that you keep track of changes to how GWT actually bootstraps its modules internally. If you are writing primary linkers, it's kind of a big responsibility because the way that the compiler generates this JavaScript changes subtly from version to version. It may have new requirements for variables that you have to provide before your GWT module is bootstrapped. You have to actually get your module up and running. So these are all things that you're going to have to keep track of, and you'll want to keep an eye on the release notes of GWT from version to version, just to make sure nothing major has changed. Small changes will come down from time to time. So if a new version of GWT comes out, you'll definitely want to be testing right away because it's possible that something may have changed. Just an example, there's something called soft permutations, which I'll talk about later in the talk. This is going to be coming down in a future GWT version. I'm not actually sure what the plan is for it, but if you are writing a primary linker, this will actually change the way your primary linker has to work. So something to keep an eye on. Pre-order linkers, they run before the primary linker, so they actually have a chance to take a look at all the artifacts before the primary linker gets them. They can potentially modify these artifacts, swap them out for something else. They're also a really good place. As I mentioned earlier in the presentation, you can send messages from the generators that run during the compile to linkers that run after the compile. If you're writing a pre-order linker, this is the best place for you to actually examine those messages that you sent from your generator and turn them into something concrete that's emitted to disk at the end of the compile. An example here, GWT actually has something called an RPC policy manifest linker. This is a special internal linker in GWT that takes a look at all of the remote services that you've implemented in your code, and it generates a serialization whitelist from it. What happens is every time you create a remote service in your code, one of these RPC policy file artifacts is emitted into the artifact set. This isn't actually an emitted artifact that ends up on disk. This is just a piece of information that sits in this artifact set until the linkers run. And then when the linker runs after the compile is done, it takes a look and can see all of the types that are used in serialization, turns them into a file which you put on the server, and that file will then whitelist all the types used for all of the remote services in your web application. And finally, of course, is the post-order linkers. These run after the primary linkers, so you have a chance to take a look at every file that's been generated by the primary linker, make changes there. It is important to note that if you don't really want to maintain a primary linker, you might have some subtle differences in how you want your web application to work from a primary linker. You could actually, instead of writing a full primary linker, just write a post-ordered linker that is responsible for tweaking the output of that primary linker just enough to actually make it work for your situation. So this way, it's the primary order linker's job to keep up with GWT changes, but you can just tweak it, tweak your deployment the way you want it, renaming files or moving files around. If it's just a subtle change, you'll probably just want to write a post-order linker. One example, of course, of a post-order linker is the offline application manifest linker. We'll talk about that in a demo in a few minutes here. We'll actually build this one from scratch. OK, so SelectionScriptLinker is something you're going to need to know if you ever actually start writing a primary linker. This is most likely going to be the subclass that you're going to use. Because there are so many things you're responsible for if you're writing a primary linker, the GWT team wrote SelectionScriptLinker as something that does all the heavy lifting for you. Every primary linker basically has to do the same things. It has to deal with bootstrapping your GWT module. It has to deal with determining the current permutation you're running. It has to deal with this developer-guided code splitting. SelectionScriptLinker is something already written for you that understands all of these things that has to be done and can do them for most primary linkers. It just needs a little bit of additional input to tell it how to work. And I'm going to explain it a little more in detail using the Web Worker linker. The Web Worker linker is a primary linker that the SpeedTracer team wrote. It is a subclass of SelectionScriptLinker, as you'd expect. And just a quick summary of what it does. It takes a GWT module and lets you load it as an HTML5 Web Worker. So by saying new worker and then the name of your module, you basically bring up another thread running your GWT module in the browser, sort of like a virtual browser thread. It's actually so simple that I've just inlined it straight into my slides here. This dedicated Web Worker linker is, it's actually amazing that the linker stack is so powerful that you can create a Web Worker linker in so few lines of code. And you'll see I've got one more slide, but the amount of code actually required here is pretty minuscule. So there are 5 methods that this linker implements. And none of these methods are actually that complicated. The get description, of course, is required by all linkers. And it's just a human-readable string of what your linker is. The next 4 methods are actually the methods I talked about before that are required for you to implement if you're a subclass of SelectionScriptLinker. Get compilation extension just tells SelectionScriptLinker what the file extension should be for the permutations it generates. Get module prefix and suffix are methods that tell the SelectionScriptLinker what the JavaScript it should put above and below the generated JavaScript from your Java code. So the compiler, when it runs, outputs something called a compilation result. It's a special type of artifact, which is basically raw JavaScript, the raw JavaScript equivalent of the Java code you put in it. But it's missing all of the important information needed to bootstrap it. It's just the raw information, the raw code for your web app. Now, module prefix and suffix let you actually surround that with whatever you need to bootstrap this application. You may have special global variables that are important. You might have, you may want to wrap it in a JavaScript function so that you don't pollute the global namespace when you load your module, things like that. But in this case, the Web Worker linker, because it's running in its own isolated sandbox, it just it returns empty strings here. It writes the JavaScript naked to disk and loads that directly. Finally, the last method here is get selection script template. This just tells SelectionScriptLinker the name of a Java resource that it's going to use to create your selection script. This is just a standard Java resource that lives next to your class file. in this case, dedicated worker template.js, which I've got on the next slide here. The selection script template, SelectionScriptLinker basically takes a selection script template and turns it into your module's selection script effectively. The template contains a number of places that are used to customize. The SelectionScriptLinker will actually replace these special placeholders with the appropriate module functions. So in this case here, you can see there's a number of placeholders. First one is module func. This is just a JavaScript compatible version of your module name. Permutations begin and end are just block markers that tell SelectionScriptLinker where to start replacing the selection script logic, etc. The permutation logic is actually where the selection script is going to figure out which browser it's running on and which language is currently selected. So what happens in the permutation logic is a number of browser checks. It'll check the user agent to see if it's running on Firefox, if it's running on WebKit. It'll run any other property checks that it might have. And at the end of the permutation logic, at the very top you can see there's a variable named strong name. That variable strong name will be populated with the strong name of the permutation that should run, given all of these properties that have been detected in this permutation logic. So then the strong name is passed into the import scripts function. Import scripts is a special function in the web worker context. What this does is it loads the file, the script file that you reference from the network or from a file, etc., and it'll block the web worker until that script is actually loaded and initialized, and then return. So at this point, our permutation is loaded. We then call GWT onload, GWT onload. This is a special function that the GWT compiler specifies that actually bootstraps your GWT application. This is part of the compilation result that the compiler output. As soon as you call this function, this effectively calls into the entry point of your module. This GWT onload, as soon you call it, and your GWT module is up and running. So as I mentioned before, this is such a simple linker, but just these few dozen lines of code are enough basically to turn a GWT module into a full HTML5 web worker. And most primary linkers, even though it does sound ominous, that there is a lot of stuff you're responsible for, in the end, most of these GWT linkers are actually fairly simple. They, in the cases where you are responsible for a lot of things, the GWT team has actually provided a lot of interesting classes that do a lot of the work for you, so you don't even have to, in the end, you're only writing a few lines of code anyways. You should be taking a look at iframe linker and access linker in the GWT source code too. If you are interested in writing primary linkers, those will kind of go through what other responsibilities you have as a primary order linker, just give you an idea of what you need to do. Okay, so this is the exciting part where we actually build a linker. Just a bit of background about this demo that we're actually going to run here. The HTML5 specifies something called an offline manifest. And an offline manifest allows your HTML5 application to run without a network connection. So you specify a manifest. The browser is then responsible for grabbing files in this manifest, making sure that they're available while the browser is offline. And then when you hit this website and there is no network connection available, the browser then goes to the manifest rather than the network to pull your application up. And I'm not going to go through the entire specification. You can grab it off the W3 site. They have an offline web apps specification you can look at. You specify that your web app is offline capable by adding a manifest attribute to your HTML element. And the manifest itself, again, is very straightforward. You add a cache manifest header. then you list out all the files that you want to be available offline for your application. It's pretty straightforward. It's just a very simple file listing the files that need to be available. Okay, so let me actually switch over to Eclipse here. Okay, so in Eclipse here, I've just got the standard GWT sample application that you can create yourself. Just a very simple demo that has a button, connects to a network service, etc. So what we want is we want to create an offline manifest for this web application so that when the user's not connected, they can still run our app. First thing we're going to do, of course, we have to open up our host page, and we're going to add this manifest. I've already added here just to save some time. We say HTML manifest equals linker demo offline manifest. Linker demo, of course, is this directory here. This directory is just the output directory of my web application. So we want to generate a file named offline.manifest that's output in the standard GWT application output directory at the end of the compile to make this web application offline capable. Okay, so why don't we start? Before I start, I'm just going to reduce the number of permutations I have to compile, because when you're writing a linker, you actually want to debug the GWT compiler. If you've been compiling your GWT application using the compile project button in Eclipse, this runs this fires up a JVM and runs the compile, but it doesn't actually run it in debug mode. What you can do, though, because the GWT compiler is written in Java, you can actually create your own launch target to debug the Java compiler. So before, let me just quickly do this. I'm going to set property, name equals user agent, value equals Safari. So I'm just reducing the number of permutations we're going to compile. Just because this is a demo, I want to rapidly iterate, compile as quick as possible. I'm going to create a new launch target. Okay, so we create a new Java application launch target. I'm going to call it compiler. And I pick the project that we've got. The main class is actually going to be the GWT compiler. So we're actually going to debug the compiler here. So under program arguments, another thing that's useful when you're writing your own linkers, there's a flag you can pass, draft compile, and this just reduces the amount of optimization that happens during the GWT compile process. So cuts a few seconds off, and this is, of course, is really useful when you're writing something that happens after the GWT compile. And of course, the next argument to the compiler is always the module you're compiling. And just so I don't mess this up, it's com Google I/O linker demo.linker demo. Finally, because GWT actually resolves the Java files that it compiles from your class path, we actually have to add the source directory of our project as a folder on the class path before we can successfully compile. Okay, so let me just hit the debug button and just make sure I got all this stuff right here. Okay, so while this waits, while this is compiling, we'll just leave this running. Let's actually start writing our linker. Okay, so I'm gonna call our linker the offline linker, and it's gonna live in the com Google I/O linker Google I/O linker demo.linker package. Okay, our compile succeeded in the background there. And actually, you'll see that after I added that set property, I'm only getting one permutation compiled. And it took significantly less time to compile. So, okay, so the offline linker that we're writing, the offline manifest requires the name of all of the files in the output of your web application. So this thing is going to have to run after the primary linker so we can actually see what files were generated. We're going to set the order of this linker then to post. All right, so the base class of our offline linker, every linker that you create in GWT has to be a subclass of linker, basically an abstract class that GWT has defined. But there is actually another subclass of linker called abstract linker. And abstract linker is just, it's basically linker with a few extra helper methods that are useful if you're emitting artifacts that end up in your web app. So if you are writing something like this, you'll probably just want to subclass abstract linker. Then you get access to these helper methods, which we'll be using in a few minutes here. So I'm going to extend abstract linker. OK, let's just add the unimplemented methods. I mentioned before, getDescription is just a human readable string. We're going to call this the HTML5 offline linker. And the link method, of course, is the most important method. This is what runs during the linker chain of the GWT compile. You can see here, I mentioned before, the linker chain is constructed by passing the output of one linker to the input of another linker. This is the input here, artifacts. We're going to create a new artifact set from that. Now, it's important to note that the artifact set passed into your linker is actually immutable. You actually can't make changes to it. You have to create a brand new artifact set every time. So I'm going to create a new artifact set from it. Oops. From artifacts. And I'm just going to return that from the linker directly. And what I've done here is actually create a pass-through linker. So this is kind of the simplest example of a no-op linker. It runs, it takes input from the previous linker, passes it out, and that's it. It's just a very simple no-op linker. Before we actually flesh this out, let's do some GWT bookkeeping and actually define our linker and tell GWT that we want to use this linker during the compile. So we have to add a new attribute, define linker. We have to tell GWT which linker we're going to be defining. So I'm just copying the full name. Oops, full name. And I'm going to name it the offline linker. OK, so this name here is the same name that you use in your add linker directive. Add linker, name equals offline. You can actually define linkers without using them. This of course, is useful if you might have a utility linker in a library. You may not, it might be optional for people to use. They'll actually have to use add linker before that linker is active. OK, so let's set a breakpoint in the offline linker, and let's fire up the compiler here. OK, so this is going to take a few seconds to get to our breakpoint. OK, so of course, linkers run after the compiler, so we're just waiting for the compiler to actually spit out the compilation results so we can take a look at them. This is going to take a few seconds here. Thankfully, we only have one permutation, so we're not waiting too long. OK, there we go. So I've actually set a breakpoint in the GWT compiler at the point where it's invoking my linker. You can see here the stack trace is full of GWT code, compiler, the link, standard linking context, and finally the offline linker. Now, if I take a quick look at this artifact set that's actually been generated, the artifact set that's passed in, you can see it's full of basically all the different artifacts that come out of GWT. So oops. You'll see some files in here that came from module public paths. You'll see the compilation results. You'll see the HTML files that were generated by, the .cache.html files that were generated by the iframe linker, things like that. OK, so let's actually start building our offline manifest. If you recall, the offline manifest basically starts with cache manifest, followed by a new line. And now we actually have to fill this, this manifest with the files that are available in the output of the web app. So let's iterate over all of the emitted artifacts in the input artifact set. So the find method is just the way to query the artifact set. Emitted artifact. Okay, so we're just looping over all these artifacts that the compiler will be emitting. Now, I'm just adding a check here for a flag is private. This is something I didn't mention before, but an emitted artifact can be private. This just means that this artifact, while it's emitted, is not actually part of your web application. This is private developer data that isn't deployed as part of your application. So if the artifact is private, we're just going to continue. Otherwise, we're going to add it to our manifest. We're going to emit the partial path. Partial path is basically just the relative path of an artifact within your web app's application directory. And finally, we'll append a new line. Okay, so thankfully we're running in Eclipse. So as soon as I save that, I can actually just continue, and Eclipse will pick up that new code. So there you go. You can see that I'm generating now this manifest. Basically, I've got the string in memory that represents this manifest that we're going to write to disk. So we actually have to emit this now to disk, because if I don't emit this, it's just going to get lost at the end of the compile. So we can create a new emitted artifact, and let's call it manifest. And I was mentioning before that Abstract Linker had a bunch of helper classes that help you to emit artifacts. One of the helpers is emit string. Emit string basically takes a string that you pass it and turns it into a file on disk. So the parameter what is our manifest. Let's get it from our string builder. And the file name is going to be offline.manifest. Okay, and this is actually just an emitted artifact. This artifact isn't actually linked to anything. Before we can actually create it on disk, we have to add it to our artifact set. So we add it to our artifact set, and now when this method returns, it's going to be in the output artifact set, and GWT is going to see it and write it to disk. So I'm going to run the code to the end here. Unfortunately, the artifact set is too big, so it's fairly hard to find it. Just going to complete the compilation. I'm going to go down here to the linker demo, and you can see the file we just created in that linker, offline.manifest, is there, and the contents of the file are basically what we put into the string. So you can see here, to write any sort of linker is really just a matter of a few lines of code. And it does seem really daunting to write a linker, but in the end, doing almost anything in a linker is, it just comes down to some simple manipulation of artifacts and emitting artifacts in the right place. So, the web worker linker is really simple. I mean, this HTML5 offline linker is extremely simple. The Firefox extension linker that we wrote for DotSpots, it's pretty simple overall. It's it's not a lot of work to do this sort of thing, and it's definitely something you should look into if you have to do any sort of customization of your web app. Okay, so I'm just going to kind of leave the demo there because I can demonstrate a web app running offline, but it's not entirely exciting. Let's just we can move on to the last few advanced notes here since we've got a little bit of time. Okay, so some advanced linker notes. I'm not going to deep dive into any of this stuff. If you have any questions, we can, I guess we can kind of visit them after the discussion, or you can always visit them on the GWT users group where there's the GWT developers are available, things like that. Okay, so going to talk briefly here about developer-guided code splitting. You've probably seen this in a number of talks already. The compiler splits fragments across GWT run async calls. What you may not have seen in those presentations is that in web mode, the run async call is basically delegated to something called a loading strategy. And these loading strategies are basically just a way for you to load the deferred fragments. So wherever you put your deferred fragments, you just need a loading strategy that's able to bring those back. There is a default loading strategy, XHR loading strategy. Source is available in async fragment loader if you're interested. And this XHR loading strategy, it's actually a bit of a misnomer because it handles more than just XML HTTP requests. It can actually delegate back to you to do your own requests. So I recommend taking a look at this class and just seeing how it works. The contract is actually really simple if you need to do it, if you need to do any sort of deferred fragment loading. So if you're writing a primary linker and you need to load deferred fragments, take a look here in async fragment loader. The information should be available. As well, development mode is new in GWT 2.0. The development mode is fairly difficult to support if you're writing a primary linker. It's not impossible. We do actually support it in our Firefox linker. We had to do a fair bit of work, and it's not something trivial to support. If you're writing a pre or post linker, though, I mean, it's the primary linker's job to deal with development mode, so you definitely can. You don't really have to worry too much about supporting it. It's fairly simple. The real differences are basically that a relink method is also called on your linker as well as a link method. You can. Your best bet for this is just to kind of try it out, and when you run into problems, just come onto the GWT user list or contributors list and just ask questions there, because the people who are knowledgeable about this sort of thing are always there to answer questions. And of course, some upcoming linker features. In an upcoming version of GWT, your linkers will be shardable and able to distribute in your distributed compiles. I don't know how many of you out there are actually distributing your GWT compiles to speed them up, but your linkers will basically be able to participate in this as well. And soft permutations, which are actually pretty exciting. I don't know when they're going to ship, but basically, this is, Bruce is shrugging over there. But it's basically what this is going to do is instead of having a hard permutation, like one permutation file per combination of properties, you can actually ship multiple combinations of properties inside a single file and switch between them at runtime. So if your permutations aren't that different, instead of generating two files which are 99% the same, you just ship one file and you pay a small runtime cost to switch between them. And this is only really applicable if you're writing a primary linker as well. This is going to change the bootstrap sequence for a GWT module. And again, keep an eye on the release notes. User group, definitely, if you have any questions. Okay, so just wrapping this up quickly so we can leave some time for questions. Linkers package, analyze, decorate your compiled scripts. They give you a much more structured approach to your output versus Ant scripts or shell scripts. They are really easy to write. They might look daunting, but once you get into it, the concepts are simple. It's simple to write them. I hope I've given you enough information from this talk to go and write your first linker in a few minutes, you know. And basically, they make GWT more powerful than just a simple web application compiler. You know, it's now a Firefox extension compiler, a Chrome extension compiler, a web worker linker compiler, a Google gadget compiler. It could be an OS X dashboard gadget compiler. You know, it just adds power to GWT. So I've got a link to the user discussion group here, and I think it'll be in the Wave as well, and presentation on the web afterwards. So I don't know if the network has stayed up during the whole presentation. I can head over to the wave here, and if you have any questions, I guess just step up to the mic and we can go through as many as we can as we have time. Oops. Sure, go ahead.
Is there any documentation for this?
I believe the linker documentation is all in JavaDoc. It's, I don't believe that there are currently specific documents written that go through linkers and everything. You basically start from the JavaDoc for the linker class in GWT and work your way out from there, unfortunately. That, I can look this up a little bit more. I can put some more information into the wave if I find any, but as far as I know, I believe it's just in the JavaDoc. Go ahead.
In the example of the manifest linker, at one point, because it's a pass-through linker, you take the artifact in and you construct a new artifact and return that. So the artifacts are immutable. Is it necessary to construct a new one, and if so, why?
It is necessary to create a new artifact set because you can actually take a look at the artifact set source code, but the artifact set passed into your linker is frozen, and all of the mutation methods will basically throw an exception. So if you called add on the input artifact set, it would throw. So you just create a new artifact exception. The reason for that is actually it makes the linker stack a little more flexible for the GWT team. They can make some changes in the future that they couldn't if the artifact sets were immutable. So it's it's not really hard to work around, so they just made them immutable so that in the future they may take advantage of it and not actually have to break everybody's linkers at the time. So I did notice there is one question in the wave here. I think this is actually out of scope, unfortunately, for this presentation. GWT and WebSockets. This might be something you'd probably want to bring up on the user group. And I actually don't know what the GWT plan is for WebSockets at this time. Go ahead, sir.
Yes, hi. The artifacts list was basically list of the files, right? So if we wanted to gain access to functions in those files or things that were declared in the source code, is there a way to get to that information, provided that we know that the GWT compiler has changed all that, has done its optimization work?
Okay, so that's a good question. The question is basically, do we have access to the type system, basically the DOM of your program in memory after the compile finishes? The answer to that is unfortunately no. But you can write a generator that runs at GWT time, which has access to some of the type and member information. I don't believe there is no real public API for the compiler right now. Like at the statement expression level, but there is. If you write a generator, you have access to the type hierarchy, all of the methods, their return types, generics, things like that. So what you'll probably want to do is write a generator and then pass that information into your linker if you need that. Unfortunately, if you need source level information, that's just not available. Go ahead.
Yeah, thanks for your talk. You mentioned several times your Firefox extension linker. Is that something that Dotspot's going to make available? Or?
Actually, that is available. You can grab that. I believe it's GWT Firefox extension on Google Code. And there's an example extension there if you wanted to play with it. I haven't tested this with the latest releases of GWT, but you can grab this, compile it, and you should be able to get an extension up and running. You can, there's a Dotspot's open source link on here if you have any questions about that, and I can definitely help you through that if you want to play around with it.
Thank you very much.
Thanks. Okay, that's pretty much all the time I have. Thanks a lot for coming.